I'm Jared Nelson.
And I'm Paul Apps, and this is our final project for ECE476 Advanced Embedded Systems, where using our stepper motor, a keypad, and our embedded systems board, we tried to create a simulation of an automatic door locking system.
Alright, so the way this thing is all hooked up, we actually just used wires straight from our breadboard here and then put them into the GPIO ports of the board and just kind of twisted them back there so they would stay in place. So the blue and yellow wires over here that are hooked here, those are for the keypad. 3 of them are inputs and 3 of them are outputs and 4 of them are inputs. So the 3 inputs go into the columns and the 3 outputs go into the columns and the 4 inputs go into the rows, and those 4 inputs just look for voltages coming through depending on what number is pressed. And then the stepper motor over here is powered by this circuit. So these 4 yellow wires are outputs coming from the board, and they go into the circuit, the H-bridge circuit that is powering the stepper motor.
So as a demonstration for our system, like a typical keypad design for a door lock, we have the user input a certain digit passcode using the keypad, which will then be displayed on our LCD screen. You can see we have a door status there that'll tell you whether or not the door is locked, and there will also be a message telling the user whether or not their password was accepted. So if we just try to enter a random passcode, you can see as I'm entering values, they kind of turn into asterisks to kind of protect the security. So this is the wrong passcode. We use the asterisk on the keypad as an enter. So when I press this, our code detected that was the wrong passcode. So it told the user, wrong code, try again, and it just went straight back to the top of the loop where it's checking for that passcode. So now if we try to enter the correct passcode that we have hard-coded into our system, there's a little bit of bounce between the keypad. We couldn't quite figure out how to get rid of that completely, so sometimes it just takes a little bit to get the right code. As you can see, there's not really a limit to how many times you can attempt to do the passcode. Okay, so now we have our correct code in there, and as you can see, it told the user that the passcode was accepted and the door was unlocked. And then our stepper motor, which is acting as a simulation for the deadbolt, is turning 90 degrees to an unlocked position, and then it's waiting a certain period of time to go back into a locked position. We're using a timer 0 interrupt to control the stepper motor so that it steps at the correct pacing, and then we're also kind of piggybacking off of that and using that to set as like almost a wait function inside of that. And then coming back over to the board, you can see after the door has relocked itself, the indicator of the door changes back to locked from unlocked, and it kind of resets. So then we can go back into trying to enter the code again, and again you can see I was able to enter it correctly, and everything seems to be working properly.